Hey guys, in this video we're going to be doing 2b.2. Our mastery learning objective for this video is being able to multiply polynomials by distributing and combining like terms. Multiplying polynomials. Distribute using any method. The method that I'm going to show you in this video is using our Punnett squares. Sometimes distributing more than one term gets a little messy, so looking at using Punnett squares helps keep everything in order. What I mean by that is 2 times our polynomial, right? 3x squared minus 5x plus 6. We are going to be distributing this to every term. We notice that we have that 2 in front, right? There's only one term here. And we have 3 terms within our polynomial. So to keep our terms all nice in order, I'm going to draw myself a Punnett square box. I have one term. And my polynomial had 3 terms, so I'm going to do a 1 by 3 box here. My 2 I'm going to place out here. And my 3 terms are going to come from the polynomial right above it. So I'm going to have my 3x squared lined up in the first box, my negative 5x in the second box, and my plus 6 in that last box. Now I can clearly see when I'm multiplying, I make sure that I multiply every number by that coefficient over 2 in the front. So again, 2 times 3x squared, I'm going to be multiplying those out. So 2 times 3, when we multiply, the variable stays the same, and we just multiply the coefficients in the front. So 2 times 3 is 6. 2 times a negative 5x, well, 2 times a negative 5 is a negative 10. Keep that variable the same, which is in x. The last number is 2 times a positive 6 is a positive 12. So that is my final answer. When I multiply these polynomials, I get 6x squared minus 10x plus 12. Because there are no other like terms, that would be my final answer. For letter B, same concept. I see that I have one term here, so I know I'm going to have one box. And then I have a polynomial of a 3, so I'm going to make sure I have 3 boxes here. Again, if you're able to distribute that without using the Punnett square boxes, that is okay. But eventually, when our polynomials get a little bit bigger, it's easier to use Punnett squares. All right, so all I did was I rewrote that polynomial, and now I'm going to multiply. A negative 5y times y squared. Now, multiply the coefficients. Negative 5 times that 1 is still going to be a negative 5. Y times y squared, remember when we multiply, we add those exponents. So y times y squared, if you need to write that for yourself, right? Y times y squared. When we multiply, we added those exponents to give me that y cubed. All right, next term, negative 5y times that positive 4y. So negative 5 times a positive 4 is a negative 20. Y times y is going to be y squared. You need to show that again, right? Y times y, they each have a power of 1. I'm going to add those exponents to give you y squared. Last one, negative 5y minus 8. Negative 5 times a negative 8 is a positive 40. Can't forget to have that y attached though, because it was a negative 5y. So final answer, 5y cubed minus 20y squared plus 40y. In order from highest degree and alphabetical order, no other like terms, so we can go ahead and move on. Well, what happens when we have something that is 2 binomials? So I use the word 2 because each of these parentheses, right, they have 2 terms. Right, this one too, x and then negative 3. This also has 2 terms. So anything that has 2 terms, we use the word binomial. Right? Bi means 2. So when I draw my Punnett square, I wanted 2 by 2. And I'm going to place every term on its own side. So for example, I'm going to put this x minus 2 up here in the front. So I'm going to have an x, I'm going to have a plus 2. You have to keep that binomial together. You cannot split it up. Likewise, I see that x minus 3. I'm going to place those terms on the left side. Doesn't matter where you place them as long as you keep the terms, like I said, together. So that x and that negative 3 must stay together. Now we just have to multiply every single box. So x times x squared. Remember, because each of those x's have a power of 1. When we multiply, we add those exponents. X times 2 is positive 2x. X times a negative 3 is a negative 3x. And a negative 3 times a positive 2 is a negative 6. Alright, when I look at all these terms, you are more than welcome to write them out, right? I see an x squared, I see a positive 2x, I see a negative 3x, and I see a negative 6. What we will see is that top corner is always going to have that highest degree, x squared, which repeats itself right there. I'm going to bring that highest degree down, and there's no other terms that I can combine there. When I look at the next terms, I see that positive 2 and that negative 6x. Those are like terms, and you will always see those like terms in our diagonal. So negative 3 and our positive 2x makes a negative 1x. I didn't really need that coefficient of 1, but I did write it. And the last term, well, we see is our constant, which is normally in that bottom right corner, kind of by itself. No other like term, so I am done and I can move on. All right, like I said, if you don't need to write out those terms, you do not have to, but you just have to be careful that you are combining everything together. All right, I have two terms here. So I have a binomial. Oh, I forgot an R there. And then here I have also two terms. Binomial times a binomial. So I'm going to have a 2 by 2. Again, I cannot split up those binomials. So this x minus 5 has to be on one side. Again, you could have made it going up and down, does not matter, but they have to stay together. Likewise, 3x plus 4 also has to be on that same side. So I'm going to write that on the left side and then keep those terms together. So 3x plus our positive 4, and now we can go ahead and multiply using our Punnett square. 3x times x. 3 times that imaginary 1 is still 3. X times x is going to be x squared. Well, because when we multiply, we added those exponents. Right? 1 plus 1 is 2. Next box, 3x minus 5 is going to be a negative 15x. 3 times a negative 5 is negative 15. 4 times x is a positive 4x. Positive 4 times a negative 5 is a negative 20. So again, you can go ahead and state all the terms. I notice my highest degree, top corner, 3x squared. My like terms come from our diagonals here, right? Negative 15x plus 4 is going to be a negative 11x. And then our last term comes from our constant, negative 20. So that has nothing else to combine with, and that is my final answer. 3x squared minus 11x minus 20. We're going to keep going on the back side there. So let me scroll down a little bit. So example E, I have the binomial x minus 1 times x squared minus 2. Two terms in each of these, so I'm going to draw my 2 by 2 again. And I'll show you that it does not matter where you place each binomial. For example, if I had x minus 1, instead of putting x minus 1 on the top, I could have placed it on the side. But I have to make sure that each of those terms stay together. Our other binomial is going to be x squared minus 2x. So again, that has to go on the other side, keeping that whole binomial together. So x squared minus 2x. Combining our like terms, we got to multiply that. X squared minus x. Remember that has an exponent of 1. When we multiply, we add those exponents. So 2 plus 1 is 3. Next term, negative 2 times a positive x is a negative. And just notice that I should have a little negative sign here. This was like plus 1. So a positive 1 times an x squared is a positive x squared. A positive 1 times a negative 2 is a negative 2. Notice here that my like terms, I have an x cubed. I have an x squared that does not have any other like terms, right? X squared, so plus x squared. My other term, negative 2x, we see that those are on a diagonal, but they are not like terms because if we look back at our binomial, this is to the second degree, right? So we're missing that middle degree, that middle term that just has an x value. And then our last constant is a -2. There is nothing to combine there, so we can go ahead and move on. Next example, letter F. We have another binomial by binomial. So 2 by 2. X plus 7 does not matter where you place these as long as you keep that binomial together. X times x squared, because each of those had a power of 1. When we add them, we add our x. When we multiply, we add our exponents. X times 7 is a positive 7x. X times a negative 7 is a negative 7x. And negative 7 times a positive 7 is a negative 49. Looking at all of these terms, x squared plus 7x minus 7x minus 49. Combining my like terms, x squared, that positive 7x and that negative 7x, those like terms, again, that we've seen in our diagonal here, is 0. All right, we don't have to write the 0 because those just drop out. And then we have our negative 49. Don't forget to bring that down. So my final answer is just x squared minus 49. Please do not write the 0 because we do not need it. The last example here, letter G. We have a trinomial. So trinomial means there are 3 terms within that polynomial. So this has 3 terms. So we call that a trinomial. Right? Tri means 3. And then this one has a binomial, so that's 2 terms. So I need a 2 by 3. Alright, my binomial here, I'm going to write my 11x and my negative 7. And then I have my 2x squared, my negative 8x, and my negative 9. Multiplying all of these out, 2x squared times 11x. 2 times 11 is 22. X squared times x to the first is x to the third power. 8x, negative 8x times 11x is a negative 88x squared again because I had a power of 1. That's power of 1. We add them together. Negative 9 times 11x squared is, or 11x is 99x. Bottom row, 2x squared times a negative 7 is a negative 14x squared. Negative 8x times a negative 7 is a positive 56x. Negative 9 times a negative 7 is a positive 63. So looking at all my terms here, I have a positive 22x cubed. It's the only cube that I have. Combining my other like terms, I see my x squareds there are on my diagonal. So negative 14 and a negative 88 is a negative 102. Do not change that variable. It is just an x squared. The last terms here, I see a negative 99x and a positive 56x. Those are also like terms. So when I combine a negative 99 and a positive 56, that is a negative 43x. And then my last term there is my positive 63. No other like terms. So that is my final answer. Remember, like in order by highest degree to lowest degree and alphabetically. And now you can go ahead and work on activity 2B.2.